A legacy system is an outdated computer system, software application, or technology that is still in use, often because it continues to meet essential business needs. These systems were typically developed using older programming languages, hardware platforms, or software frameworks, and may not be compatible with current technologies. While they may no longer receive updates or support, they remain critical to an organization's day-to-day operations. Legacy systems can be found across various industries, such as banking, government, manufacturing, and healthcare, where they often handle large volumes of data or complex processes that have been in place for years. One of the main reasons legacy systems continue to exist is the cost and risk of replacement. Replacing a legacy system can be extremely expensive, time-consuming, and risky, particularly if the system is deeply integrated with other parts of the organization. Many businesses are reluctant to disrupt existing operations for a large-scale migration, especially when the legacy system is functioning adequately. Additionally, over the years, these systems often accumulate customizations that are hard to replicate in modern platforms, further complicating the transition. However, legacy systems pose significant challenges. They are often difficult to maintain due to a lack of available expertise, especially if the original developers have retired or moved on. Furthermore, outdated technologies may not meet current security standards, leaving the organization vulnerable to cyber threats. Performance limitations and integration difficulties with newer software can also reduce operational efficiency. These limitations become more critical as customer expectations and competitive pressures demand greater flexibility and faster innovation. To address these issues, companies often adopt strategies like encapsulation, modernization, or replacement. Encapsulation involves wrapping the legacy system with modern interfaces, such as APIs, so that it can interact with newer applications without altering its core code. Modernization might include replatforming, moving to newer hardware or cloud, recoding, or re-architecting the system. Full replacement, while risky, can provide long-term benefits, such as lower maintenance costs and improved scalability. A successful transition from legacy systems often involves careful planning and incremental change. Organizations may start by identifying critical functionalities that need to be preserved, mapping data flows, and gradually shifting parts of the system to newer platforms. As industries become more digital and customer-centric, the ability to adapt quickly to change is vital. Relying on outdated technology can hinder innovation, slow down product development, and limit responsiveness to market trends. Organizations that modernize their legacy systems not only reduce risk, but also gain a competitive edge through improved performance, agility, and scalability.